Alright, so we're going to start with the hematopoietic family tree. So this is how red and white blood cells, as well as thrombocytes, are divided and differentiated from a stem cell line. We start up here with the progenitor stem cell. This is the hematopoietic stem cell. This is going to be the progenitor of all the different stem cell lines. The red blood cells all the way across to our granulocytes, our agranulocytes, and our platelets, which are our thrombocytes. So I'm going to start from one side and I'm going to work my way over. So I'm going to start with the red blood cells. So our stem cell becomes our proerythroblast, and then that will lead us to our early erythroblasts, then to our intermediate, and then to our late erythroblasts, and then to our reticulocytes, and then to our red blood cells. Now, as we move from our proerythroblast to a red blood cell, our nucleus is going to become more and more condensed, and our cell structure and our cytoplasm is going to become redder and redder and redder as we produce more and more hemoglobin. Our nucleus is condensing, and we are going to eventually extrude the nucleus in order to make more space for more hemoglobin. That's the ultimate purpose and goal of the red blood cell. Now, if you'll follow me over here, we're going to move this over here. A red blood cell is going to be a round. It's going to be a round biconcave disc with a round biconcave disc. So it's going to be round and flat, and it's going to be have a divot in the center. This is in order to increase its surface area to volume ratio. In order to maximize its surface area, as opposed to having just a disc shape, this is going to have more surface in order for more gas exchange to occur. Because for simple diffusion of gases, we want greater surface area. But we need to maintain a certain small size of smaller than about 7 micrometers in order for it to fit through our capillary networks. So we want a very small size. But we also want a significant surface area in order for these cells to really maximize their gas exchange. Now, we're going to move back over. Those are our erythrocytes. Erythro meaning red in Greek. Now we're going to move over to our granulocyte family. Granulocytes are good old American cells. They're going to be red, white, and blue, literally. Now, we have our stem cell, progenitor stem cell, will divide and differentiate into our myeloblast and then our progranulocytes. Now, our progranulocytes is going to divide into our 3 different cell types. We're going to have our red eosinophilic myelocytes, which will eventually become eosinophilic band cells to eosinophils. And then our white neutrophilic myelocytes to our neutrophilic band cells to our neutrophils. And then our blue basophilic myelocytes to our basophilic band cells to our basophils. So red, white, and blue. Good old American cells. Alright, so granulocytes are red, white, and blue. So those are eosinophils, neutrophils, and basophils. Now, those are our granulocytes. Now, if you'll follow me over here to draw them, they are all nucleated, and they all have, they're all rounded with a multinucleated I'm going to draw a neutrophil first, by the way. So I'm going to connect these here. So this is going to be our neutrophil. I'm not drawing any granules in there because they stain clear. They don't have any they don't have any stains, so they stain neutrally. That's why they are staining white. They have no stain. They stain neutral. All right, so this is going to be, and I'm going to be writing this upside down. You know what? I'm going to flip this over. Neutrophil. Flip that right back over. So that's my neutrophil. Now, I'm going to draw my next one. I'm going to erase that extra line in order to make this, Cambridge appropriate. All right. Now, erase your lines better on the Cambridge exam, because if this gets scanned and that line is still visible, you will lose a point. So, my next one, I'm going to make myself here a bilobed nucleus. All right. And what I'm going to do is I'm going to do the closest thing to shading that I've ever done that I'll ever do in any kind of diagram for Cambridge, and I'm going to make dots. But I'm going to label these dots with a label line. Now, this label line, I'm going to flip this over so I can label this in the right side up configuration like I did before. I'm going to label this as an eosinophilic granule. Oops, spelled it wrong. Eosinophilic granule, and so that makes this my eosinophil. Alright, now this here is a bilobed nucleus, so that makes that my nucleus. That is also my nucleus. Alright, turn that back around for us. Alright, so multi-lobed nuclei here, and a bilobed nuclei here. So my next one is going to be a bit smaller, because my basophils are going to be my smallest cells of my granulocyte type. And this time I'm going to draw a trilobed nucleus because I feel like it, and also because you can have a bilobed or a trilobed nucleus in eosinophils or basophils. And I'm also going to do the same thing that I saw here before, where I'm going to have basophilic staining granules that I had in my eosinophils. And I'm also going to label these. Alright, I'm going to label these the same way that I labeled my eosinophils before. Alright, so with these, I'm just going to mark that over, flip this over the same way. Basophilic granule. That's my nucleus. By the way, when you make these label lines, you should use a ruler in order to make these label lines. Don't do what I'm doing and just freehand it. That is not acceptable. Alright, do as I say, not as I do. Alright, so that would make this a basophil. Okay? So this is how you would draw a diagram of these three types of cells. This is the only time where you're doing any sort of quote-unquote shading of these diagrams. But this isn't technically shading. This is technically drawing organelles. These are granules. So these are technically vesicles filled with endocytic. These are technically endocytic vesicles filled with enzymes. So you're not technically breaking any rules here by drawing and shading. Now, these are your individual cell types. Now, we're going to go back over here, and we're going to our agranulocyte line. Now, granulocytes had granules in them. Agranulocytes, as you may be able to tell by the A, means without, and these are going to have no granules. These are going to be cells without granules. Now, my lymphocytes are going to have my stem cell line differentiate into my lymphoblast, my immature lymphocyte, and these are just going to directly become lymphocytes. And then my monoblasts are going to be my immature monocytes, and these are only going to be found in the blood. We're going to discuss lymphocytes and monocytes much more detailed in Unit 5. And I mean much more detailed in Unit 5. We're going to have a long discussion about these. So these agranulocytes. And we will have a discussion about how to draw these then. Now let's talk about the megakaryocytes and the platelets. So platelets down here, these are thrombocytes, but they're not cells in and of themselves. And despite what you may see here, these don't really necessarily need to be drawn as organelles. These are really cell fragments. These are pinched off cytoplasmic extensions of a megakaryocyte. So a stem cell from over here is going to differentiate into a megakaryoblast, which is an immature megakaryocyte. So a megakaryocyte is going to give cytoplasmic extensions from the bone marrow out into the bloodstream, and those bloodstream extensions are going to break off and become those platelets. Now, platelets are thrombocytes, and they're going to be very important for the clotting of blood in the healing of bleeding and damage to vessels and what have you. All right, and with that, we're going to switch back to our normal layout.